Assalamualaikum students. I hope you all are doing well. Today we'll continue our chapter number 5, chemical reactions, and the topic we'll study today is the law of conservation of mass. This law was proposed by French scientist Antoine Lavoisier, who is considered as the father of modern chemistry. He not only recognized the most common non-metals, oxygen and hydrogen, but was also amongst those scientists who have developed the metric system. Now, metric system is a system used for measurements. Like the most recent metric system is the International System of Units, SI unit system. He has also confirmed that although matter may change its form, but the total mass remains constant. This law states that during a chemical reaction, mass is neither created nor destroyed, but it changes from one form to another. Now you must recall for a chemical reaction that the substances which take part in a chemical reaction are called as reactants, and the substances which are formed as a result of the chemical reaction are called as products. So we can say that during a chemical reaction, reactants are converted into products. Now, this law states that during such chemical reaction, the total mass of the reactants is equal to the total mass of the product. How did Lavoisier prove this? Lavoisier proved this by using certain special instruments for the measurements. Experimental verification of law of conservation of mass. Now this law can be proved by performing a very simple experiment in the laboratory. We'll take a conical flask and inside it we'll place a test tube. Now sodium chloride solution will be taken in the conical flask, and before inserting the test tube inside the conical flask, we'll add silver nitrate solution to it. A cork is fitted at the mouth of the conical flask in order to make it a closed system. Now, what's a closed system? A closed system is a system in which no substance can enter or leave the system. Now, the two reactants, that is silver nitrates and sodium chloride, are allowed to mix with each other. When these solutions are allowed to mix, it is observed that white precipitates of silver chloride are formed and sodium nitrate solution is formed in the conical flask. Now you must see that silver nitrate and sodium chloride are the two reactants, and the silver chloride precipitates and the sodium nitrate solution are the products. You must not ignore the reading on the electronic balance that the mass of the reactants before the chemical reaction and the mass of the products at the end of the chemical reaction is exactly equal to each other. We'll also study later that not only the mass, rather the number of atoms of the reactants and the number of atoms of the products must also be equal to each other. And if in a chemical equation they're not equal, we'll make them equal by balancing the chemical equation, but that will be our next topic. Now there was trouble with some gases. There are many chemical reactions which give off a gas. Because of this, the mass of the remaining solid and liquid products is less, rather appears to be less than the original mass of the reactants. Before Lavoisier, many scientists thought that this was proof that mass was destroyed. Lavoisier understood what was happening, and he developed a device to trap the gases that were given off during a chemical reaction. Then he performed many experiments where he showed that the mass of the products, including the gaseous product, was equal to the original mass of the reactants. Now we'll consider certain examples in order to clarify our concept. The first one is the common reaction photosynthesis, with which you must be familiar. The carbon dioxide and water react together in the presence of sunlight to form sugar and oxygen. Now here the total mass of the reactants is equal to the total mass of the products. Next is the reaction of iron with sulfur. When sulfur reacts with iron, it forms a new product, iron 2 sulfide. So again, the masses of the reactants, if we take the sum of the masses of the reactants, that will be equal to the total mass of the product. Now let's take some examples which include burning. The very first one amongst the list is burning of natural gas. Now natural gas is that gas which you are commonly called as Sui gas in Pakistan, because it was found in the Sui in Balochistan first. Now natural gas is not only used in domestic appliances, in stoves, heaters, geysers, it's also used in vehicles in the form of CNG. Now methane reacts with oxygen to form carbon dioxide, water vapors along with energy. So this one is the combustion reaction. Surprisingly, the mass of the carbon dioxide and water vapors released during this reaction is slightly less than the mass of the methane gas or natural gas and the oxygen. Now, does it mean that burning of natural gas does not hold law of conservation of mass? No. There is another product which we haven't discussed yet, is that the energy is also amongst the products. Thanks to Einstein's famous equation, E is equal to mc square. So if apparently it seems that the mass of the product is less than the total mass of the reactants, then we are ignoring the energy here. So the loss of mass is equal to the energy released. Hence we can say that the mass of the reactants is equal to the mass of products plus the energy which is released. Now energy can be released in the form of heat energy or in the form of light energy. And you know that whenever burning takes place, not only it releases light energy because you can see light, rather you also feel that heat energy is released, as we'll feel some warmth. So again, recall the statement of the law that matter can change its form from one form to another form, but it can neither be created nor be destroyed. So sometimes the mass is converted into energy according to Einstein equation, but it is not destroyed. Second, amongst the burning, and fourth in the examples, burning of candle. Now apparently it is quite clear that at the start the candle's mass is more and at the end the candle mass is less, but now you must know that the law of conservation of mass states that the mass of the reactant must be equal to the mass of the product, no matter what you are observing apparently, because number one, there are some gaseous products, number two, that some mass is converted into energy. So burning of candle is a combustion reaction and it will obey the law of conservation of mass. The wax of the candle, which is here the fuel, in the presence of oxygen will react together to form carbon dioxide and steam, and light energy and heat energy is released during the reaction. So the chemical equation is here. The wax, candle wax, particularly called as paraffin wax, reacts with oxygen gas, and the carbon dioxide gas and water vapors are formed along with the release of the energy. Now these coefficients in the chemical reaction, that is the number before the symbol of the element or the formula of the compound, these are responsible for balancing the equation, and we'll discuss it in our next topic. So for the time being, you must know only this, that the paraffin wax reacts with oxygen O2 and the product of the combustion are here carbon dioxide gas, water vapors and energy. Next example is burning of wood. Now, when the wood is burned, it leaves behind ashes. So, ashes are much lighter than the wood. So, Does it mean that it doesn't hold law of conservation of mass? No. It Burning of food is a combustion reaction and it obeys the law of conservation of mass. And again the same equation that wood when burnt in oxygen, it will yield ashes, carbon dioxide gas, water vapors and energy. Energy can be either in the form of light or in the form of heat. Here you must also know that if there is insufficient supply of oxygen, then an other product will also be formed which is called as soot. Soot is the black deposit which consists of amorphous carbon, and that is commonly observed that whenever wood is burnt or coal is burnt or some gas is burnt, what happens that along with the ashes there is black residue of carbon which is left. That is called as soot. Soot is a product formed during the incomplete combustion. I hope you have understood the law of conservation of mass. Till next topic, balancing of equation. You must prepare this topic very well. Thank you.